A Chinese AI company you've probably never heard of just dropped an open-weight model that beat GPT-5.4 and Claude Opus on the hardest coding benchmark in the world. Okay, so here's the full story. On April 7th, Zhipu AI, the company behind SWE-AI, released GLM 5.1. It's a 754 billion parameter mixture of experts model, and it scored 58.4 on SWE-Bench Pro, which makes it the first open-weight model to ever hold the #1 spot on that benchmark. For context, GPT 5.4 scored 57.7 and Claude Opus 4.6 scored 57.3. But the part that makes this genuinely weird is that the entire model was trained on Huawei Ascend 910B chips. Not a single NVIDIA GPU touched this thing. And they published the weights on Hugging Face under an MIT license, which means you can download it right now, fine-tune it, ship it in a product, and owe nobody anything. Let me give you the numbers that actually matter here. 58.4 on SWE-Bench Pro, the highest score ever recorded by an open-weight model. 754 billion total parameters with only 40 billion active per token, because it's mixture of experts. 200,000 token context window, which is massive, and it ships under MIT, the most permissive license you can pick. Zhipu went public in Hong Kong back in January. They're sitting at a $44 billion market cap, and they've been mostly flying under the radar in the West while DeepSeek gets all the attention. But this release changes that conversation. Let me show you what's actually in the model. Let me walk you through the GitHub repo because it tells you everything you need to know about how Zhipu thinks about this model. Right at the top, you've got the title, GLM 5, from vibe coding to agentic engineering, which is a pretty clear statement about where they think the industry is going. Below that is the performance evaluation section, and this is where it gets interesting. You can see the bar charts comparing GLM 5.1 against Claude Opus, GPT 5.4, and Gemini 3.1 Pro across SWE-Bench Pro, Terminal Bench, and NL2 repo. On SWE-Bench Pro, the GLM bar is clearly the tallest. Below the coding benchmarks, there's a section on long-horizon agentic evaluation, and this is really the headline capability. They show this chart of optimization progress over hundreds of iterations, and you can see the model just keeps improving the target metric without plateauing. Further down, there's what they call the coding performance trajectory, which compares GLM versions over time against the Claude and GPT families. The line is clearly trending upward faster than any other open-weight model. And at the bottom of the page, you've got the community contributions section and the citation information. So why should you care about yet another big model, especially one from a company most Western developers haven't heard of? A few reasons. First, this is the first time an open-weight model has topped SWE-Bench Pro outright. DeepSeek v3 was impressive, but never claimed that spot. Second, and this is the part that geopolitics people will lose their minds over, the entire thing was trained without any NVIDIA hardware. Every training run happened on Huawei's Ascend 910B chips, which means the US chip export restrictions didn't slow this down at all. Third, it's not just a benchmark model. Zhipu showed it running autonomously for 8 hours straight, doing over 1,600 steps without degrading. That's a fundamentally different capability than just being good at one-shot code generation. Let me give you the full benchmark spec sheet because the numbers tell an interesting story. On SWE-Bench Verified, it hits 77.8%, which is only about 3 points behind Claude Opus. On Terminal Bench 2.0, it scores 63.5, and with tools enabled that jumps to 68.9. CyberGym is where it really shines, 68.7%, which is a 20-point jump over the previous GLM 5. And on AIME 2026, the math competition benchmark, it scores 95.3. The headline feature of GLM 5.1 isn't the benchmark score, it's the long-horizon agentic capability. Traditional coding models generate code in a single shot. You give it a prompt, it writes some code, done. GLM 5.1 is designed to stay on a single job for hours. In their demo, they pointed it at a vector database optimization task and let it run. Over 600 iterations and more than 6,000 tool calls later, it had taken the query throughput from 3,500 queries per second to 21,500. That's a 6x improvement, and the model made 6 independent strategic pivots during the process, including switching to a clustering approach around iteration 90 and building a 2-stage pipeline by iteration 240. That's not code generation, that's something closer to autonomous engineering. The other demos are equally wild. They had it build a complete Linux desktop environment from scratch, running for about 8 hours in an autonomous feedback loop. No starter code, and it produced a functional web-based desktop with a file browser, terminal, text editor, system monitor, calculator, and games. On GPU code acceleration, it achieved a 3.6x speedup on machine learning training code, which is competitive with Claude Opus on that specific task. And there's one more thing that's easy to miss. The model doesn't just run until it runs out of context window. Zhipu claims it maintains coherence and keeps making progress across hundreds of iterations, which they specifically designed around with what they're calling dynamic sparse attention, or DSA. Most models start degrading around iteration 50 or 60 because the context gets noisy. This one apparently doesn't. Under the hood, the architecture is a mixture of experts transformer with dynamic sparse attention, which is their custom attention mechanism that keeps compute efficient even at 754 billion total parameters. Only 40 billion parameters are active per token, so inference costs are way lower than you'd expect for a model this size. The model supports a 200,000 token context window with up to 128,000 tokens of output, and it deploys through VLLM, SGLang, or Hugging Face transformers out of the box. There's also an FP8 quantized version on Hugging Face that cuts memory requirements roughly in half. And the fact that it runs on Ascend hardware means there's a whole separate deployment path through XLLM for organizations already on Huawei infrastructure, which is a bigger audience than most Western developers realize. If you want to actually use it, you've got a few options. The easiest is their API on bigmodel.cn, which runs about $1.40 per million input tokens and $4.40 per million output tokens, with cached input at 26 cents. If you want to use it through your existing coding tools, they sell a GLM coding plan for $10 a month that plugs into Claude Code, Klein, OpenCode, and anything else that speaks the OpenAI API format. And if you want to run the weights locally, the FP8 version is on Hugging Face and deploys through VLLM or SGLang with a few commands. GLM 5.1 is technically a post-training upgrade of GLM 5, which launched back in February. Same base architecture, same 754 billion parameters, but the fine-tuning for agentic execution is new. The jump in real-world capability is huge. CyberGym went from around 48 to 68.7, which is a 20-point gain from post-training alone. SWE-Bench Pro went from the mid-40s to 58.4. And the long horizon capability, being able to run for hundreds of iterations without degrading, is entirely a product of the 5.1 training. Zhipu also raised API prices by about 10% alongside this launch, and their stock price jumped almost 19% intraday on the news, which tells you the market thinks this is real and not just a benchmark press release. So who should actually be paying attention here? If you're building AI-powered developer tools, you now have a genuinely competitive open-weight alternative to Claude and GPT for agentic coding tasks, and you can self-host it without per-token API costs eating your margins. If you work in enterprise and your org has concerns about data leaving the building, running a model this capable on your own infrastructure with an MIT license solves that problem cleanly. If you're doing anything in the Huawei or Ascend ecosystem, this is the strongest model that runs natively on that hardware, period. And if you just follow the AI space and want to understand the competitive landscape, the fact that a Chinese company trained a frontier coding model entirely without NVIDIA chips is probably the most strategically significant thing that's happened this quarter. Okay, let's be honest about the trade-offs because the story isn't all roses. On reasoning benchmarks, GLM 5.1 is clearly behind the leaders. Humanity's last exam scores 31% versus 45% for Claude and 39% for GPT, which is a significant gap. On the broader coding composite that includes Terminal Bench and NL2 repo together, Claude Opus still leads at 57.5 versus GLM's 54.9. And if you actually want to run it locally, 754 billion parameters is enormous. Even the FP8 version needs serious multi-GPU hardware. This isn't something you're spinning up on a single consumer card. But for everything that's imperfect, the project is real and the trajectory is steep. It went from the mid-40s to first place on SWE-Bench Pro in a single post-training cycle. It's MIT licensed, the weights are on Hugging Face right now, and it was trained entirely on non-NVIDIA hardware, which means the chip restrictions aren't working the way everyone assumed. If you build AI coding tools in 2026 and you're not at least evaluating GLM 5.1 alongside Claude and GPT, you're leaving options on the table. Links are in the description. Thanks for watching. I'll catch you tomorrow.